Hi everyone, this is the final performance task for calculus of group 1 and I am Nico Agripo with my group mate Don Escarda, Lord Lingat and Terence Corquez. So we're going to show you how to solve these problems, and without further ado, let's go and show you how to do it.
Let us proceed to the problem. There are two posts, one is 12 feet high and the other is 28 feet high, and they stand 30 feet apart. They are to be staked by two wires attached to a single stake running from the ground level to the top of each post. So the question will be, where should the stake be placed to use the least amount of wire? So in order for us to solve this problem or to answer this question, we have to follow or do the optimization steps and strategies, and I'm going to tell you what steps are these. So the first step is either to draw a picture or to identify the key informations. So what are these key informations? The first will be shape. What is the shape that we are looking for? Is it triangle, rectangle, square, etc.? Next will be if we are maximizing or we are minimizing. And the last key information will be the equation of shape. So the next step will be to utilize two equations to make one differentiable equation. Next step is to use substitution of one equation into the one being maximized or minimized. That will lead us to one variable. Next step is to find the first derivative and to find the critical value. And that would lead us to the last step, which is to solve for the missing value in order for us to know where should the stake be placed to use the least amount of wire. So now that we know these steps, let's proceed to solving the problem. Our shape equation is a Pythagorean theorem. So we have a squared plus b squared equals c squared. Since we are dealing with the total length of wire, we are going to add two triangles together. So we have a squared plus b squared plus a squared plus b squared is equals to c squared. Simplify this equation and let a squared plus b squared be a squared and a squared plus b squared be b squared, then equal to c squared. Since we have c squared, we need to square root both sides to remove the squared. Substitute our given value to a squared, which is 12 squared, and the missing c, and substitute the value in our b squared, which is 28 squared, and 30 minus x, since we will be using the remaining number of x from 30 feet. Simplify these terms. 12 squared is equal to 144, and then 28 squared is equal to 784, and then use the FOIL method to 30 minus x, which we will get 900 minus 60x plus x squared. And lastly, substitute it to our final formula, square root of a squared plus square root of b squared equals square root of c squared. And let c be WL, which is wire length. So this is the illustration.
Now, after getting our formula, which is the square root of 144 plus x squared plus the square root of 164 minus 60x plus x squared, and then converting it into raising it to 1/2, since this equation right here is raised to 1, and then since it is a square root, there is 2 here, so we can place it as 1 as our numerator and 2 as our denominator, so we can get 144 plus x squared raised to 1/2. And then same with the other side, this equation is raised to 1 and then squared to 2, so we can place it as numerator and then denominator, and then 164 minus 60x plus x squared raised to 1/2. Now, after getting our formula, we can now proceed to our first derivation. So since this is a plus, we can use a sum and difference, so we can just, and we can also use the chain rule. So we have here a power rule, so 1/2, we're gonna bring that into here, times, you just copy our equation, which is 144 plus x squared here, so 1/2 times 144 plus x squared, and then 1/2 minus 1 is equals to -1 half. And then we're gonna derive 144 plus x squared, which is 144. Its derivation is 0 since it is a constant, and then x squared, we're just gonna place 2 here, so 2 times 1, and then 2 minus 1, so that is going to be 2x right here, 2x. And then next is for this equation, we're gonna bring down 1 half here, and then times our equation. We're just gonna copy it, since so 1684 minus 60x plus x squared, and then 1 half minus 1 is equals to negative 1 half. So we're gonna write negative 1 half here, and then the derivation of this equation right here. So it is, since it is a constant, since 1684 is constant, we can write that as 0. And then negative 60x, there is a 1 here. So we're going to times 1 into negative 60. That is equals to negative 60. And then 1 minus 1 is equals to 0. So we can mark that as nothing. So it is only negative 60. And then x squared, same as the other side, we can bring down 2 here. And then 2 minus 1 is equals to 1. So we're going to write 2x. Now, the next step will be simplifying, or combining, like simplifying, yes. Since there is a 2x here, we know that this 2x is over 1, and then we have 1 half here. So we can cancel this since it is equals to 1. So that is only x remaining. And then for the other side, we can factor out negative 60 plus 2x, which is 2, since 2 times x is equals to 2x, and then 2 times negative 30 is equals to negative 60. So we can factor that out, number 2. So we can cancel 2 since we have 1 half here. So that is equals to 1 as well. And then we're gonna rewrite that. So since there is a negative 1 half, we can write that as our denominator. So we have still an x here. So x over this one, so we can write this into our denominator. The negative 1 half will be a 1 half only. So x is over to 144 plus x squared raised to 1 half. And then for the other side, it still has a negative 1 half. So we can bring that down to our denominator. So we can write x minus 30, since there is 1 here. So you just plus or I times that one. And then 1 times that equation is equals to that equation also. So negative 30 over 1684 minus 60x plus x squared raised to 1 half. Since we place our negative exponent into our denominator, is going to be a positive. And now, since we have our first derivation, we're going to equal that into 0. And then we're going to transpose this equation right here into the other side, and that would make it this one. So x over 144 plus x squared raised to 1 half equals, since we transposed a positive sign into the other side, we're going to make that into negative. So we have a negative sign here. We're going to times that into x and then to the 30. Now, the next step, we are going to cross multiply this equation. So x times the denominator, and then this one times our denominator in the other side. So x times this equation right here raised to 1 half, and then since we have transposed this, it's going to be negative x, and then it's going to be positive 30. So write that here, and then times it into 144 plus x squared raised to 1 half right here. Since we have an exponent of 1 half both sides, we can just raise both sides into 1 half to cancel out that 1 half. So what we're going to do is, since we are going to raise both sides by 2, we're going to raise x by 2, so that is going to be an x squared. And then since it is 1 half here, and we know that there is 1 there, so this will cancel out and will make just 1. So we 1 here. And then as for the other side, we're going to raise negative x plus 30 to 2. So we're going to need to use the FOIL method for this one. And for the FOIL method, right here we can write the two equation. For the FOIL method, we can use first, for the f, first, negative x times negative x is equals to x squared, since negative times negative is equal to positive, and then we know that there is an exponent 1 here on both sides, and then multiplying exponents will just add them, so we have x squared. And then next is 30 times negative x, and that's going to be negative 30, and then times that by 2, since the outer part is still the same as the inner, so we can just times that to 2. So we have negative 60x, and then 30 times 30 is equals to 900. So back to our equation. Now we're gonna write that as is. So x squared times this equation without the 1/2, and then our FOIL method of this, we're gonna write x squared minus 60x plus 900 times here, since it is 1/2, and we know, since same as the other side, there is a 1 here, and then that is going to cancel and don't make it to 1. So 144 plus x squared raised to 1, so we don't have to write it. And then we are going to times this side, so we're going to distribute x squared to 1684, and we're gonna distribute it to all of the terms here, so negative 60x, and then x squared times x squared. So x squared times x squared is equals to x raised to 4, and then x squared times negative 60x is just negative 60x cubed, since we know that we have a 1 exponent here, so an exponent times an exponent is just a addition, so we have a cube. So x squared times 1684 is equals to 1684 squared. And then for the other side, this is a trinomial, so we're going to distribute 144 to all the terms, and we distribute x squared to all of the terms as well. So x squared times x squared is just equals to x to the 4th, or yeah, and then x squared times negative 60x is equals to negative 60x cubed, since we have an exponent 2 here and an exponent 1 right here, so that is just an addition of exponent. And then x squared times 900, we can write that as 900 x squared, and then for the next one is we have 144 times x squared is just going to be 144 x squared, and we can add that, and that's why we have 1044 on this side. So we just added these terms, okay, since they are alike. And then 144 times negative 60x is equals to negative 8640x, and then 144 times 900 is equals to 129,600. And then we're just going to combine like terms and transpose. So since we have a x fourth and x fourth in the other side as well, so we can just cancel that out. And then we have negative 60 cube and then negative 60 cube in the other side as well, so we can just cancel those terms. And then we're going to transpose negative 1684 squared to the other side, and then we can write that as is. So if you're going to transpose, we have 1044 squared. But if we're going to transpose this term, 1684 squared, it's going to be a negative, so it's going to be a minus 1084 squared, and that is equals to negative 640x squared. So that's why we have a negative 640x squared right here. And then we're just going to copy our 8640x, that is going to be negative, and then our 129,600. So we have this equation. So since we have our equation now, we can just factor it out to find our x. So we can place all of this equation divided by 220 to find its factor. So 320 divided by negative 640 is equals to negative 2, and then 320 divided by 8,640 is equals to negative 27, and then 220 times divided by 129,600 is equals to 405. Now we are going to factor out this equation right here. So we had negative 2x minus 45 times x minus 9, and then we can verify it to make sure that it's factored form. So first term is negative 2x times x is equals to negative 2x squared, since 1 exponent and 1 exponent here. And then the inner part is negative 45 times x is equals to negative 45x. And then for the outer term is negative 2x times negative 9, that is equals to positive. So we have 2 times 9 equals to 18x. So, and then lastly, negative 45 times negative 9 is equals to positive, since negative to negative. So we have 405. And then combine like terms, 45 and this 18. So we have negative 2x squared minus 27x plus 405. So it is correct. Now back to our factored form. We're going to transpose negative 45 to the other side to get an x. So negative 2x equals 45, and then divide both sides by 2x to cancel this out. And then we have 45, our x is equals to 45 over negative 2, or negative 22.5. And then our x minus 9 transpose 9 to the other side, that we are going to have a positive 9, so x equals to 9. And then let's go back to our domain. So we have a domain of a 0, and then it will be less than x, and then x is going to be less than 30. So we have here negative 22.5. that is going to be out of the equation, since it is a negative form, it is lesser than 0. So we have 9 here, and yes, we can use 9 since it is positive and it is closer to 30. So next is we're going to go back to our formula which we had earlier, which is here. Wire length is equals to square root of 144 plus x squared plus square root of 1684 minus 60x plus x squared. Now, since we have x here and x there, we can just substitute our 9 here. But first, we are going to try if we assume that our x is 0 and 30. So now we're going to assume that our x is 0, so we're going to substitute 0 to these x's. So square root of 144 plus 0 squared is, and then plus square root of 1684 minus 60 times to 0 plus here, so we have 0 squared. So we're going to substitute those one, place it in our calculator, and we're going to have the value of 53.04 feet. Feet, since we are looking for the feet, since we are looking for the least amount of wire that we are going to use, and our unit is feet. So here we're going to assume that our x is equals to 30. So we're going to substitute 30 to x squared, x and x squared. So square root of 144 plus 30 squared, and then to the other side plus square root of 1684 minus 60x times 30 plus 30 squared. We have the value of 60.31 feet, which is kind of big. So now we're gonna use our x here, which we had. So now we're gonna substitute 9, or we're gonna substitute 9 to the x's in this formula. So the square root of 144 plus 9 squared plus square root of 1684 minus 60 times 9 plus 9 squared, and we're having a value of 50 feet. Now, we can see here that if our x is 0, we are going to have the total length of wire of 53.04 feet, and then we are going to have if we assume that our x is 30, we're going to have a wire length of 60.31. And then if we assume it is 9, we're going to have 50 feet. And then now, we can see that, or we should remember that we are looking for the least amount of wire that we can use regarding our problem. So, in these three equations right here, in these three examples, we can see that the least amount of wire we can use is when our x is equals to 9. So now, we're going to have 50 feet, or this is our final answer. Now, this is our minimal, since we're looking for the first derivative, and then it's x.
Hello and good day everyone. Today I'm going to discuss to you related rates. Now, what is a related rate? A related rate involves two or more variables that change at the same time or possibly at different rates. Now, in a problem, there are very different kind of things that you can consider depending on its solution or depending on its requirements within the problem. Now, in this topic, I'm going to discuss to you the formulas or the equations of rates. Now, one of the best examples for this, which is most likely more familiar to all, is the velocity. Now, that is a rate because it considers time, right? Now, we can say that the point 1, let's say point 1, we have a car driving at a speed of 10 miles per hour. And then at point B, now it reaches, let's say 20 miles per hour, right? So there, we can consider that there is a change in rate, right? Because in time, in a point of time there, the change of rate between them could be 5 or 10, depending on each minute that the speed in which the rate of the car changes. Now, in order to further understand this, we have a sample question. An airplane is flying at an elevation of 6 miles on a flight path that is directly over a radar tracking station. If the distance between the radar station and the plane is decreasing at a rate of 400 miles per hour and the plane is 10 miles from the radar station, what is the velocity of the plane? Now, in order to solve this equation, you have to first draw a diagram in order for you to understand it more effectively. Now, the way that I understand it, it does says here that the plane is flying at an elevation of 6 miles over the 6 miles. So I'm just going to draw a circle, right? I mean, I don't really have to draw a square like a literal plane. So let's say this is the ground. I don't know if you can see there. Let's say that's the ground. I'm sorry if it's not straight. It's the ground, right? So it does says that it's flying at 6 miles. Right, that's miles. So it's flying at 6 miles, right? Thus, that is directly over a radar tracking station. So let's say that our tracking station is right here. That is over the radar. So then it does says here that the plane from the radar station is 10 miles. That is 10 miles, right? Their distance is 10 miles, and then you have 6 elevation. And then at which, the rate of which, that their distance is decreasing at negative 400 miles per hour. This is our rate. Once again, rate talks about time. So the distance between the plane, I'm gonna mark this as P, I'm gonna mark this as R, S is the radar station, at which the distance between them is decreasing at a rate of negative 400 miles per hour. Now, in this in this distance, right, there's a change of y there, or there's a change of the horizontal factor, right? So I'm going to mark this as y because as we are going closely to the radar, there's a change in a horizontal factor. Now, next is that we have to determine which rate are given and which rate do you need to find. Now, we have a rate, which is this, and then our rate that we should need to find is the velocity of the plane. Right, is the velocity. Okay, so now with a new marker, I'm very sorry for that. So, in order for us to find y, we have to use the Pythagorean theorem. Now, why Pythagorean theorem? Now, Pythagorean theorem is very applicable in this because we have the given x, y, and then the distance between here. Now, the Pythagorean theorem can only be used when there is a right triangle form. So yeah, that's it. Now for the solution. Okay, so now for the solution. Now we have a height. Oh no, where is it? Now we have a height of 6 miles. We have a height of 6 miles, and then we have also a change of, or a rate of which the distance between the plane and the radar station is negative 400 miles per hour. So in that rate, we have to consider the derivative, right? So derivative, what is that? Yes, we can consider as derivative s over t is equals to negative 400, and then for our s, we have 10 miles. So once again, in our drawing, I'm going to put the drawing here. I'm going to draw first. Wait. So that there will be no confusion. There, this is our plane, our x-axis, our y-axis, then our s. So there. After that, since we are finding y, we have to use the equation of the Pythagorean theorem, which is s squared x squared plus y squared. Right? Since we are finding y is equals to the square root of excuse me, s squared minus x squared. That is y. So square root, our s is equals to 10. That is 10 squared minus our x is 6 squared. That is equals to square root of 100 minus 36, right? Square root, that is 36. That should also equate to square root of 64. And so the square root of 64 would be 8. So that is equals to 8 miles, right? So therefore, your y here is 8 miles, right? So now that we have this equation, so that we have the value of the y, we can be able to solve again the Pythagorean theorem using derivatives, since we are determining the rate. Now, once again, the derivative, or just my thought about it, a derivative is a instantaneous rate of change. So, in order for us to find the velocity, since that is what we're looking for, or that is now equate to dy over dt, since our negative 400 miles per hour is ds over dt, t is equals to time. So next would be the derivative of s squared is equals to x squared plus y squared. Right. So s squared, the derivative of s squared is 2s over ds over dt. And then the derivative of x is 2x, that is what? Dx over dt. Right? And our y is, the derivative of y squared is y, 2y dy over dx. I hope this is very clear. There. Right. So, now the next thing to do is to substitute all of the values available within this equation. Right? So our s, we have the value s, which is 10. And then our ds over dt is negative 400, since that is the rate of change. Right? So 2, our s is 10, our ds over dt is negative 400. Write that down. 2 times x, our x is 6, right? Our x is 6. Now what to do if you don't, now what to do for the dx over dt? Now, since we are looking for the rate of change within the horizontal value, of course we don't have to consider the dx over dt, right? There's no change in the x value, so we could consider that as a 0, or in a sense the plane is not actually landing, right? So we could consider that as 0 plus 2. Your y value is, once again, the one that we just solved is 8. I'm just going to write this down. Then our dy over dx is unknown, since that is our velocity, that is what we are looking for. So we have to state that n, dy over dt. So we have to simplify them all. 2 times 10 is 80, times negative 400, that is negative 8,000. 2 times 6 is 12, times 0, that's 0. Plus 2 times 8 is 16. So you have 16 dy over dt. Now, next step to do is to let dy dt in, right? Since that is what we are looking for. So we have to divide everything by 16. So you're left with dy over dt is equals to negative 800 over 16. 800 over 16. Now after that, we can find that dy over dt is equals to negative 500 miles per hour. Now, this at which the plane, it's its velocity, right? So this means that if it is in negative values, no, it means that the plane is slowly decreasing its course towards the radar. So now that is our final answer. It is negative 500 miles per hour, right? In our question, if we go back to it, with our given, no, with the second sentence, if the distance between the radar station and the plane is decreasing at the rate of 400 miles per hour, and the plane is 10 miles from the radar station, what is the velocity of the plane? So that would be all. Thank you.
So that would be all. Thank you for watching, and I hope you learned something. Bye.